and let me rephrase that. We're going to use our definition of a negative exponent and then our quotient rule. So for instance, I want you to take a look. We have x to the negative 2 power, right? How can I make x to the negative 2 power positive? Well, I can just move it up to the numerator according to the rule. And so I'm going to write this kind of sideways so you can see what I'm talking about. If I move it up, then I now have x to the power of 3 times y to the power of negative 5 times x to the power of 2, and the only thing left on the bottom is y. But now we have another issue. We have the negative 5 on top. Well, I'm going to use that rule again, and I'm going to take this y to the negative 5 power and move it to the bottom. When I do that, if I put 1 over y to the negative 5th power, then that's going to make that 5 positive. Anytime you move anything up, imagine you're putting a 1 on bottom and you're multiplying it to everything on the bottom. Anytime you move something from the top, imagine you're putting a 1 over the top, multiplying everything on the top by it, and it's moved to the bottom. So we're just using that rule that says we can flip these exponents to change them from positive and negative. So if I take y to the negative 5, move it down, I now have y to the positive 5. You see what I did? I just moved it to the bottom, and now I can erase it. So I'm going to rewrite it, because I moved this down. My 1 was on top, and I multiplied the 1 out, and everything on the top stayed the same that was remaining. So I'm going to rewrite it down here. We now have x to the power of 3 times x to the power of 2 over y times y to the power of 5. And doesn't that look a lot better? All positive, all positive. So at this point, we can go ahead and do the next step, which is we can go ahead and put our powers together. Notice that we don't need to necessarily use the quotient rule at this point. I thought we were in the beginning, but now that I'm looking at it, we don't need the quotient rule because we don't have any like bases. Notice that x and y, they're different bases, right? And if they're different bases, we don't use the quotient rule and subtract the powers. But we can use the product rule, because since I moved this one up and this one down, what we can do is we can just simply multiply this across. Now in the beginning, we could have used the quotient rule to go ahead and subtract the powers. I could have said x to the power of 3 minus negative 2. And I could have said y to the negative power of 5 minus the power of 1. But do you see how that you could have done it that way? And that's the thing about exponents. You can do these many different ways. But I think it's easier to just move this down, move this up, get everything positive, and then work it out with the product rule. That's my personal preference. You can do it a different way if you'd like. You'll still get the same answer either way. So now what we're going to have is we have x to the power of 3 plus the power of 2 over y to the power of 1 plus the power of 5. Because we remember, whenever we multiply, we add the powers. There's a power of 1 there, and there's a power of 5 there. So then we have x to the power of 5 over y to the power of 6. And that is my final answer. Alright, now just for grins, I took the same exact problem, and now instead of using that negative exponent rule, I'm actually going to use the quotient rule, because I think there might be some of you who are going, hey, well, what would have happened if I'd done it with the quotient rule? What would have it looked like? And I think it is important for you to see, so we're going to work it out. So if I use the quotient rule, then what I'm going to do, actually I'm going to scratch that out, I'm going to go down. So I have x to the power of 3, right? And remember, anytime we're dividing like bases, we're going to subtract the power. So I would have x to the power of 3, notice this is a negative 2, right? Minus, and you'll have to carry the sign. If you use this quotient rule and you have a negative exponent, you're going to have to carry the sign with it. Let me clear that up just a little bit. So you'll have x to the power of 3, which is this one right here. I'm crossing them out as we use them, minus negative 2. That got rid of this one. And then right here, what you'll have is this one's negative, right? And this one's going to be positive. So then you would have y to the power of negative 5 minus the power of 1. Remember that there's a power of 1 for this one on the bottom. That takes care of this one and that one. So now let's go ahead and work this out. So then we're going to end up with x and notice that we have a negative times a negative, right? So we need to make sure that we always put this, if it's a negative 2, we're going to carry it up. We're going to put that in parentheses because we don't want to lose that negative sign. And if we do that, I want you to remember that a negative times a negative gives you a positive. So we're actually going to add the powers, 3 plus 2, and that's going to give us 5. And then y to the power of negative 5 minus 1, well, those are both negative terms. There's no multiplication going on, so we're just going to subtract it. So y to the negative 6. Now we still have a problem here that you notice, I'm sure, is that we have a negative exponent in our final answer. So how do we fix that? We use that rule that says x to the power of 5, and then we just move this down to the denominator, right? Which is going to give us y to the positive 6. And if you wanted to see, if we wanted to follow the rule perfectly, we could say, well, we're going to move y down, so we're going to say 1 over y. And if I put a 1 here, right, you're just going to multiply it to the x, and it's just going to come out to be x over 5, y over 6. Same exact answer as the other problem. But I think you will probably agree, a lot of you, that this is a lot more work. Having to deal with this negative power and make sure that you distribute. I think it's more work. I think it's easier if you did it this way, right here. You just flip this one to the top, flip this one to the bottom using the rule, add the powers, you're done. So your choice, you can do it either this way, or you could go ahead and use the quotient rule, and then at the end use that rule in order to move the negative exponent to the bottom. So the definition of a negative exponent. So whatever you like best.